When I started my job in Nebraska, 97 to about 2002, 2003, the GMO acceptance starts going like a straight line. And about 2002, 2003, we almost had like 80% of beans were Roundup ready. And then I got really bored of like, what the heck am I going to do with weed science? How many ways can we spray Roundup? So Nebraska started creating an organic research group, and they were looking for a weed scientist to jump on board. So there were 7 of us. We wrote some grants and received some funding, and that's basically what got me into flame weeding. By training, I'm a weed ecologist, but I do work with chemicals, so don't hold that against me, guys. It's just the name of the game when you're a public scientist, especially my appointment is research and extension. Extension means working with public, so I do a lot of my research is very, very applied research, and the information that I gained this year, my farmers can use in their farm next year. So anyway, so I work with chemicals, I work with other chemicals, but this literally the organic world brought a lot of light into my life, and we basically, you can see the years here where we did intensive research using flaming as a method of weed control, but everybody was out there spraying Roundup like crazy, for a lack of a better term. And a lot of my colleagues were doing research with Roundup. I said, you know what? You guys can have the Roundup. I'm going to try to do something different. And we got into flaming, and we wrote a bunch of grants. And at one point of time, I had a little over $1 million, almost $1.5 million. I can't even remember now, in different grants to explore this flaming as a method of weed control. So originally I started this with my technician John, and I have a PhD student, one PhD student and one postdoc. And then second, third year, I guess the money starts coming in. We had about 6 or 7 different grants running anywhere from 150 to, we had a couple of $600,000 grants, of which I had about a couple $100,000 for flaming. So you can see the list of people. That started to work with me. I've been going to European meetings, international meetings, so I had a lot of people from different countries. You can see here the names of the countries, the students that came to Nebraska. At one point in time, I think I had like 18 people working in my program just on the projects of flaming. Anyway, and then I got George Gogos, a colleague from mechanical engineering. I noticed some issues, and I'll talk about that later through some of the slides. Some issues with the equipment that was available on the market at that time, and I'm talking about that 2000 to 2000, whatever, 4 or 5. A lot of stuff that George and I, as the lead scientist, dreamed up to do on our small plots and everything. We were fortunate to have about a group of a dozen or so organic farmers, mostly from Nebraska, and we were replicating some of our research on larger acres, and that basically confirmed that what I'm going to share here is kind of, I became a believer that flaming does have a role in weed control. I'm not selling flaming as the only tool. There's no such thing as the only tool for weed control. We published a bunch of 20 or so papers, abstracts. We also basically everything that we did here in about a 7-year period, I also put it into a flame weeding manual. Some people call that now kind of a D publication to go to. When it comes down to flaming, I'll mention that in here. It's free. You can download it from the website. If you don't have any, just shoot me an email. I'll send you a PDF. And basically, over the next 25 minutes, I'm going to try to summarize some work that we did in those 7 years. So anyway, flaming, how does it work? Basically, you have this little torch. You have this little torch here that will shoot a flame We'll shoot a flame that's about, let me see if I have, yeah, there's some of the machines that we started using. This was done like in the evening. It was really cloudy, and you can see the heat there. So this torch will shoot about 2,000 degree flame, 4 foot long or so. And let's go back. So basically you have a 2,000 degree that comes out of that machine, and it's a non-selective in nature. It means it's gonna hurt the crop, it's gonna hurt the weed, it's gonna, if you keep it there for longer than a second or 2 or 3, if you have a lot of residues, it's gonna catch it on fire, you know, and all those things. So it's a non-selective method, and basically you have energy that's being transferred from that flame, which is about 2,000 degrees Fahrenheit, and this is what you need. You need about 130 to coagulate or basically kill the proteins inside the plant, and then also you need about 200 or so degrees to boil water inside the plant tissue. So basically that's how flaming works. You know, you are running that heat across, and it is boiling the moisture or the water inside the plant tissue, and that's basically it disrupts the proteins. You get a cell wall breakup, and the cuticle burned from the heat, and then the water just evaporates. So basically we are not burning plants, physically burning plants. You know, if you're, and typically you drive about 4 miles an hour with this technique, 4 to 5 miles an hour. If you drive slower or if you stop, obviously you're going to incinerate things or you're going to burn it. So that's in the nutshell how flaming works. Literally a few seconds after that machine goes through, you grab a leaf. If you get a watermark like this, thumbprint there, that's the evidence that this leaf is affected. Basically, plant tissue is like human body. You know, if you cut yourself, the blood is going to start shooting out because our body is under pressure. The plant tissue is under pressure, and the fact, you know, if you break a leaf off, you can see a little sap maybe drop, a 2 or 3, whatever, depends on what kind of plant leaf you break off. But the fact that, you know, you get a thumbprint there, that means that the internal structure of that leaf is beginning to disintegrate, and that leaf will die. So we started originally with some very crude, very basic machines here, and I'm not ashamed to show this because prior to 2005, I didn't know jack about flaming, and I'm not, like I said, ashamed to admit that. 5, 6 years later, I go all over the world, teach flaming like some kind of an expert. It's amazing how life sometimes plays. Anyway, so we started with this basic setup. I was just testing the concept. We had torches, we had plumbing, we had a little tank, and we planted a bunch of different crops and weeds. Here, those are my students that worked on the project. This particular fellow, Jaimo, he was from Brazil. He was a tall guy, and his job, he was tall and had long arms, and his job was to manually ignite all these torches. You turn the propane on with the pilot light, and he will ignite with this torch. On the end of the season, the poor guy didn't have any hairs on his arm. So, you know, it gives you an idea how that could be. Anyway, so this is, like I said, this is a bare bone beginning when I was just trying to get a feel for this. And we noticed right away the way this picture is showing. You get a flame coming down, and by the simple law of physics, the flame is going to go down, it's going to rise. And when I looked at it, that for the second time after we've been trying this, I said, wait a minute, couldn't somebody think of putting some kind of a shield or something to capture all this field, all this heat here? This is all wasted energy and everything. Long story short, I got on the phone, I talked to some people down from the company that was selling the torches. They said, we don't need any of that. I said, okay. I called around, and I found a colleague from mechanical engineering, George Gogos. He jumped on board. We started testing some of this stuff in the lab, We went out, started doing it in the field, and then a year later, we got a prototype machine that had, this is pretty crude. This is a very first prototype. We were so proud of it. Our own students put a smiley face on it, and everything. I'll show you some more pictures. Like any other machine, basically you have a tractor that you can pull this with. You drive tractor in a certain speed. You have plumbing system on this. You can adjust the pressure. Basically, you have a liquid propane in here, and then you get plumbing, and the liquid goes all the way into torch, but inside the torch is a little proprietary piece of equipment in there, which has patent on it, obviously. It's an evaporator, and that converts the liquid into vapor. Vapor gets ignited, and you get the flame floating. So basically, you can set up this like you are setting up any piece of equipment on how many gallons per acre you want to have. Most of our work was done at 4 to 6 mile a gallon speed, and the pressure 40 to 60 psi, which brings you into that range of about 6, 8 to 12 gallons per acre. Propane is now at $1 a gallon or so, and then that's basically cost you with about $10 an acre for the control. And then we started getting more and more into these machines, and this was the second generation with these hoods. You keep the heat down below. It doesn't burn the crop. The torches work down below, and then smoke the weeds. We use here about 9 gallons per acre. You can see a few photos. There's all kinds of videos that we have on this. And then this is an 8-row unit. Now there's a 12-row unit as well. And now there's also a company in Nebraska that makes these machines. We also worked with a lot of farmers. This is a farm just outside of Jefferson, Iowa. He used some old tank there anyway, and this is a 16-row flamer. Actually, this is a flamer cultivator, and this guy, I don't know, you guys probably, those of you that are from Iowa or not, it's a Scott Shriver farm. He's a pretty big farmer there, and he worked with us and used our design, and he's pretty happy using this machine for flaming and cultivation on the same time. And basically, this is what it's showing here, a flamer cultivator. A lot of guys were telling me, hey, Steve, we appreciate what you do with flaming, but is there a way that we could just flame a band over the crop row and continue our cultivation? And I said, sure, maybe I can look at maybe developing a machine that does both things at the same time. Long story short, we took one of these cultivators, we took some of the shanks out, dropped in a really small tiny torches that we developed, and on the end, there was a little prototype that we've done quite a bit of research. Nobody sells this machine. There's only a big broadcast, what I call the broadcast machine, which is you've seen on these pictures here. These are available, and these torches you can flip. You can keep them horizontally. It's like a cowbell shape, and they will give you a broadcast band, or you can flip them sideways, and they'll give you a band over the crop row. You can set it up however you want, and then you can cultivate in between. Okay, so we've done a lot of work on different weed species, and a lot of that information is in the weed guide. There's some nightshade and velvet leaf before and after flaming. We did a lot of rates, consumption. I'm going to bore you with any of my science and statistics here. We were basically trying to figure it out, how much propane does it take to kill some of these weeds. So these are the 8, 7, 12 gallons per acre, depending on how big are the weeds. So this is a field bindweed, and then I can go through probably 30 slides here that have different weed species, but that's not the point of this presentation. I just want to give you a snapshot of stuff we've done. So you can see here, bindweed, kochia, morning glory, redroot, pigweed, most of them. I don't know why this shifted on the projector when it's on my slide. It looks okay, but you can see the rates: 8, 12, 12, 14, 12, gallons per acre. Here on the Venice Mellow, Waterham Foxtails, Barnyard grass, about 8 to 10. When you get to grasses, you need a little bit more heat, So anyway, and also obviously, as part of this research, we want to see which crops we can use it in, and are we going to hurt the crops or not, and so forth. Long story short, we did it in 7 crops: field corn, sweet corn, popcorn, soybean, sorghum, sunflower, and wheat. So I'll show you some photos here from corn and from soybeans and sunflower. I don't have much of the picture of sorghum and wheat. And all this information is in that manual. So these are some pictures, field shots. This is that right after flaming. As you can see, this was our 4-row unit. Our plots are usually 4-row plots. So you can see how these 4 rows, the leaves are kind of sagging down because that was just right after flaming. A day later, that's what 1 day after treatment. You can see here the area where we flamed, how we nipped some of the corn leaves, and then the weeds are all dying there, and there's a healthy weed population in this side of this plot area. This is kind of a ground photo, so you can see how the leaves were nipped in that corn, but that's nothing. The corn bounced back and there's no problem. Long story short, again, like I said, these are just the snapshots. We developed the recipe for flaming, and in any of the 3 corn types that we mentioned here, corn is extremely resilient to flaming. I don't think you can even kill it with the flame unless you really stop and you incinerate the plants. And the reason for that is that the growing point of corn is below the soil surface, all the way up to about a V6, V7 stage, and the heat doesn't penetrate the soil. And then so it's all protected. So we can flame corn anytime, all the way up to canopy closure. So and you can do 2 shots per season. So like I said, corn is extremely resilient to it. These are some shots of the plants flamed at V3 stage. This is 1 day after flaming, and then 7 days later, the plant just continues growing because the growing point is down below, and it keeps pushing that plant up. 14 days later, the plant's recovered completely. This is a V6 corn flamed, and we will nip some of the bottom leaves. The loss of that leaf area didn't impact the potential yield, and I actually have scientific publications published on this in international literature in each one of those 7 crops. And that's how you made a name internationally. And now I have a project in Italy, I have a project in Greece. In fact, one of my PhD students from University of Pisa from Italy, if you know where the Leaning Tower of Pisa is, I actually have a picture of there. Marco as a student, and he's doing now flaming in Italy, developing machines for flaming weeds on sidewalks and streets and around historical sites, because Europeans don't want to use chemicals for weed control in the cities and parks and all that. And then we also have a project in Greece where we were using flaming handheld machines for flaming weeds around historical sites, monuments, and all that. And as you guys know, Greece is full of it, and Italy as well. And they're using that in combination with some of the mechanical means and hand weeding, because they stopped using chemicals in the city parks altogether because they're finding chemicals in their drinking water and all that. So they stopped doing all that. So they're exploring some alternative methods. They're using some steaming and hot foam and a bunch of other methods as well. So anyway, so let's go back to agriculture situations here. So this was corn. We've done a lot of research in soybeans, and soybeans are pretty tricky. You can hurt the beans really bad if you don't know what you're doing. Again, I'm trying to make a long story short here. You can flame the beans at the cotyledon stage when they start cracking the ground, which is basically what you see here. These cotyledons are full of moisture, they're fat, they're full of moisture, and that heat is not going to hurt them much. It may nip the edges, brown the edges a little bit, but they bounce back. And then from that particular stage, which is actually a pretty short period, we're talking about it lasts only like 4 or 5 days, 6 days, depends on the temperature and all that. So you better get the job done during that period, or don't flame in that period at all, and then stay away from flaming up to about a third trifoliate. So you don't want to do it on this stage. That's a unifoliate stage, or this is a 2 trifoliates. And the reason why you don't want to do on that stage is because the growing point is exposed, is above the ground. So that's the main difference between grassy type crops and the broadleaf crops, that the growing point is above the soil surface. If you run that flame, in fact, if there's only one thing you want to remember from this presentation, is that you do have a 2000 degree flame coming down, and you have a growing point either of a weed or of a crop, and if those two kiss each other, it's going to be a kiss of death for the growing point, basically. And so that's why the beans, you cannot flame on those. Believe me, guys, I burned a lot of beans while we were doing. In fact, I almost burned $2,000 worth of money on the research. So anyway, so the beans will lose definitely if you flame them on those earlier growth stages. So you got to get them to grow at least about a V4 stage or so they can have some height, so you can drop your hood down and the flame down further below. You'll nip some of the bottom leaves. The nice thing about soybeans that the base of the soybeans gets pretty woody relatively early in the season, so it's not going to hurt them there, and then you're good to go. You can flame. So okay, and this is some shots of beans flamed at the cotyledon stage. You can see how they these cotyledons here are a little nipped around. Even some of the leaves here got affected a little bit, but the plant kept growing and growing, and there was any yield reductions. And then the same as when we flamed a little bit later. You can see how I nipped the bottom set of branches or the leaves, but that didn't impact any. There was no any yield reduction or so. And like I said, we do have if you want to read a scientific paper that was published, I can't remember, because I had 20 or so papers published in different journals around the world. I think this one was published probably in either Weed Science or European Crop Protection Journal. I can send you all kinds of literature if you want to read about it. Sunflower, similar situation like with soybeans. You want to flame it at the cotyledon stage, and then later on you got to wait till you have about a couple about 4 or so pairs of leaves, because the sunflower in the beginning will have like 2 or 3 pairs, and after that it goes a single leaf. So you want to wait to get some height. Again, the whole idea with getting some height in beans and sunflower is that the growing point is above the flame and it doesn't get affected. If you flame them earlier when it's like this, then you're going to hurt that sunflower. And I'm talking about you can get 60-70% yield reduction in soybeans if you flame them. If you flame them on these particular stages, those beans won't even yield 5-6 bushel. That's how you're going to hurt them. So anyway, and okay, and so like I said, all this is written in a really user-friendly publication, this manual. And if you want one, you can just shoot me an email and I'll send you I'll send you this. This is available on the National Propane Research Council website to download for free. A lot of photos. But every year I do a flame weeding workshop, which is a full day workshop on flaming on my at the station, which is north of here in Concord, Nebraska. That's like from Sioux City, Iowa, about 40-mile crow fly. University has a research station there. And then we do our flame weeding workshop there. It's a full day program. We start at 8 o'clock in the morning. I know some people here that attended that workshop, and it's always in August. I think this year we may run it August 19. Or 18. We haven't set the date yet. And then basically You basically listen to me for about 8 hours, lectures, and then we go out and we demonstrate the machines. I'll have beans and corns planted and different heights and everything, so you can actually see how the machines work and everything. And that program, like I said, we're going now into year 8 or 9. Can't even remember, to be honest with you, because there's so many activities. But what I'm trying to say here, I limit the class to 40 students, and every year is completely sold out. I have people from Florida, from New York State, a lot of guys from California. I have these rich guys from California fly their private jets to Wayne, Nebraska. They land there, they rent a car, and they come and spend a whole day with me, and I teach them about flaming. And I get so many requests to actually teach this in California, but I don't want to do it. I want them to come to Nebraska. So anyway. So that's basically, oh, okay. That's basically all what I had for flaming.